So in section 3.7, we're going to talk about variation problems. And variation problems, they usually pretty much all come the same way, but they're very useful in the real world. They establish relationships of direct variation, indirect variation, and so forth, these different types. And then we can use the numbers and predict things, and it can be very useful to us. Okay, so the first type is we're going to talk about, sorry about that. We're going to talk about direct variation. And this is the model that y equals k, that's the letter k, x. So x and y are your variables, and k is a constant. Sometimes they say a constant of proportionality. Okay, so that's the model. So I'm going to give you the example that I usually use in class. Let's say you sell lemonade. You live in the desert, it's hot, people get thirsty. And you find that when the temperature goes up, so as it gets hotter, the temperature's going up, you find that your sales go up. That's direct variation, okay? All right. So maybe when it's 100 degrees, you sell 2,000 cups of lemonade, something like that. So what that means is when your temperature, so let's see, sales, we would say sales, in this case here, talking about the temperature getting hotter and sales going up, sales varies directly as temperature. Okay, so if S is sales and T is temperature, then our relationship is S equals K. We don't know what the constant is, but there's some constant in there, times T. Now this is an example of if you go back here and you look, this is linear, right? Like you could graph that and stuff. Okay. Anyway, we're saying this is the relationship. And then we have this example that when the temperature is 100, we sell 2,000 cups of lemonade. Okay, we can put that in then. 2,000 would be the S, and the 100 would be the temperature. Now that's an equation we can solve. You just divide by 100. And so you get your constant to be, what is that, 20? Okay, then you can write a model, S equals 20 times T. So then if you know what the temperature is, you can multiply it by 20 and you can predict what your sales are going to be. That way you know how many lemons to buy and how much sugar to buy and things like that. Okay? So they're very useful, and that little example with the lemonade is how direct variation works, and it's pretty much how we set up all the problems. Okay, just one thing I want to mention. They can say varies directly or is directly proportional to, something like that. Okay, so the strategy for solving variation problems, it's just like what I showed you. It's pretty much 4 steps. Okay, write an equation that models that statement. So when we said sales varies directly as, and then as soon as you put the equal sign, put the K, because there's always going to be a constant. Sales varies directly as temperature. Okay. Then you have to find K. They're going to give you enough information to find K. They'll give you one example of a situation so you can find K. Then you're going to write the equation with the K, like ours was S equals 20T. And then they're going to have you answer some question. Either they're going to tell you the temperature and you predict the sales, or they'll tell you the sales and you predict the temperature. Okay, so here comes an example. Now, this video is taking a little while because we're trying to explain everything about variation, but the strategy doesn't change. Okay, the volume of blood B in a person's body varies directly as body weight W. Okay, that sentence tells us the relationship. B, blood, volume of blood, varies directly. That's your equal sign, and then right away put the K. And it varies directly as body weight, W. Okay, there's the relationship. That's step 1. Okay, now they're going to give us some information about a particular time so we can find K. A person who weighs 160 pounds, okay, so that's the W, has approximately 5 quarts of blood. Okay, so we've got the blood at 5. We don't know what K is, that's what we're trying to figure out. And the weight is 160 pounds. Okay. So then we're just going to divide by 160 in this case. And then you can leave that K as a fraction. Let's see, 1 over 32. Yeah, okay. So I probably would just leave it as a fraction like that. All right, it's probably easier than getting some long decimal. You really don't want to round off K because that would make a big difference in your answers. Okay, so we found K. So now we can say the blood, the volume of the blood, is 1 over 32 times the weight. Okay, so now if you tell me how much a person weighs, I can tell you what I think, how much blood they have. Or if you tell me how much blood they have, I can tell you what their weight is. Okay, it says estimate, because you're estimating. This is a model. We're estimating the number of quarts of blood. So we're trying to find B. And the person weighs 200 pounds, so we know W. Okay, so B equals 1 over 32 times 200. So I grab a calculator. These are definitely calculator problems. Let's see. Turn on my calculator. I can't see. And I'm going to take 200 and divide it by 32. And what do I get? I'm getting 6.25, I think. Yeah, it's kind of dark in my room. The blood is 6.25 quarts, right? Okay, so we're going to stick with the quarts. So we think this person has about 6.25 quarts. They might round that off to 6 or they might round it off to 6.3, but it wasn't a lot of decimals, so I'm just going to put 6.25 quarts. Okay, so that's the basics of variation problems and an example of direct variation.